Welcome, everybody. We're going to get started in just a minute here. All right. Hello, everybody. Good afternoon. My name is Kenya, and I'll be your host as we discuss Log4Shell Live Hack, a hands-on actionable fix guide with our speakers, Micah Silverman and Eric Smalling. This is presented by Snyk and hosted by Virtual Intelligence Briefing. So today's webinar will be about 45 minutes or so, and we'll save the last 10 to 15 minutes for Q&A. So please go ahead and use that Q&A button in your window to ask questions. And of course, we'll do our best to get to all the questions today. And for those that we don't get to, we'll definitely follow up after. And now, without further ado, I'd like to hand it over to Director of Developer Acceleration at Snyk, Micah Silverman.
Good afternoon, everybody. My name is Micah Silverman, and I'm pleased to be here with you today. I'll do a brief introduction and then allow my partner here, Eric, to introduce himself, and then we'll jump right into it. So I run DevSecOps Acceleration at Snyk, which doesn't tell you maybe a lot about what it is, but I run our Stranger Danger program, which is all about learning about vulnerabilities and remediations and hopefully hands-on fun ways. And I'm working on expanding that program. So keep an eye out for the public sessions that we run twice a month for that. My background is a Java developer program. I've been writing in Java since it was released in 1995. So this is usually when I invite people to get off my lawn, but I do a lot of other stuff too. I know just enough to be dangerous in Python. I know a lot of JavaScript. But today we're going to be talking about Log4Shell. Let me give Eric a moment to introduce himself, and then we'll jump right in.
Thanks, Micah. My name is Eric Smalling. I am a developer advocate on the developer relations team here at Snyk, and been here for a little bit over a year. My background also is development. I did about 30 or 20 of my 30 years of my career as a C, C++, Java, looked at JavaScript and ran away screaming. Just kidding.
Smart.
It's fine. But last decade or so has been mainly in what we would call the DevOps skills, doing a lot of consulting around build automation, CI/CD, and I've been in the container space for quite a while. I'm a Docker captain, and I have all the CK Kubernetes certifications that you can get right now, except for the brand new one they just added, which is kind of an intro one. But anyway, I'm here to talk the container side of the house, and when we get to that, I can't wait to show you some stuff.
All right, very good. So here's what we're going to be talking about today. We're going to look at what exactly is Log4Shell, look at its anatomy. We'll see it in action and look at some remediation, the best way to approach dealing with it. Then Eric's going to guide us through Log4Shell in containers, and we'll wrap up with a deep dive into Log4Shell. That is, I've set strategic breakpoints in the Log4j stack, and we can see how our humble logger got to the point where it could make all kinds of external network calls and get us into trouble. We'll make sure that we have time for Q&A as well. So the TLDR here is right around December 10th, a very easily exploitable critical zero-day vulnerability was disclosed, affecting the very popular Log4j2 framework. And it was dubbed Log4Shell because we'll see in just a little bit that, among other things, you can get shell access or remote code execution. The important thing to remediate is you need to identify where you use Log4j2 and upgrade to version 2.17.1 as of this webinar. It has gone through a few iterations since it was first disclosed, but we seem pretty stable so far at 2.17.1. It's been out for about 45 days now. It's stayed at 2.17.1, so it looks like we're pretty stable there. And we have a full remediation guide with our amongst our resources with this remediation cheat sheet, and we'll be looking at that in more detail a little later on here. One thing I want to say at the outset, the second bullet point, identifying where you use Log4j, that can be tricky sometimes because you may not be using Log4j at all, but you may have a dependency that has Log4j as its dependency. So transitive dependencies can make it a little challenging, but we'll look at some of the tools that help you to dig deep and find everywhere where you might be using Log4j. What is Log4j? Now, if you're like me, I kind of forgot about logging a number of years ago because logging just became ubiquitous, and whatever framework of the day I was using, mainly Spring Boot these days, it just had logging built in, and I just used it when I needed to. I kind of forgot about it. Turns out that Spring Boot uses a mix of SLF4j and logback, so wasn't actually affected by this, but it is pluggable. And you can drop Log4j into Spring Boot. And a lot of other frameworks use and libraries use Log4j by default. So it's very popular. The Apache Foundation took it over a while ago and provides fast, flexible, reliable application logging. And beyond system.out.println, it gives us the ability to save our logs to databases, to send our logs to services like Sumo Logic to give us nice aggregated views of our logs. But with that expansion and capability came this problem. And we'll look at the roots of it, like where it all began a little later. A spoiler alert here is that Log4Shell, what we now know as Log4Shell, has been kicking around in the stack since 2013. So that gives you a little insight into some of these vulnerabilities. Sometimes they're buried in a stack for a long time before they get discovered and exploited. So the short story with preventing Log4j, as I said, is upgrading. Now this slide is a little out of date, so you do want to make sure that oh, see, I gotta update this in real time. I thought I caught them all. This is what we call the demo monster. We're up to 2.17.1 now. So let me take that again, 2.17.1. But back on December 10th, our Snyk's own Brian Vermeer, Java champion, wrote our first blog post disclosing and providing a proof of concept about how to exploit it. And it received the highest score possible, which is not a good thing in this case. You don't want high scores. It received the 1,000 score because it was so exploitable, and the result of the exploit would be a complete takeover of a machine potentially. Now, one thing I will say about this is we have continually updated all of our resources, the blog posts, the videos, that we provided, all of the resources, which we're going to get into as part of this, and they all have the latest and greatest information. So even though this slide may be slightly out of date, if you go to any of these resources, you'll see they all talk to 2.17.1 and have the latest and greatest information. One of the things, if maybe you're not aware of kind of the progression and how we iterated over this, and it really kind of highlights the double-edged sword of open source software. The vulnerability was first discovered in version 2.14.1. And as the situation evolved, developers, mainly volunteers on the project, started making updates to try and fix the problem. And the emphasis was really on fixing it and getting rid of this vulnerability as soon as possible. So as sometimes happens, we needed to go through a few iterations to really get it right. So a first attempt was made with 2.15 and 2.16 and 2.17, and each time additional vulnerabilities were discovered. They weren't as serious, but there were denial of service vulnerabilities that were discovered. And we'll see in a little while that ultimately the networking stack that enabled Log4Shell, ultimately the decision was made to just rip that out so that it wasn't even possible to do this in the future. Now, what presentation wouldn't be complete without a poorly drawn diagram? And here's mine. This is Log4Shell in a nutshell, and there's kind of a lot going on here. So we're going to return to this, but I'll give you a brief overview now. And what we're looking at is how our humble logger came to be able to make a lot of network calls in service of logging. So at the top here, what we're looking at is a Jindy string set up inside the $ curly brackets, which is interpolated, and that kicks off a deep dive into the stack. And kind of the root cause of all of this was support for Jindy, the Java naming and directory interface within Log4j. Now, I'll show you some references a little later on that support a use case for, you might ask the question, well, why was Jindy even added to Log4j? And there's a reasonable answer for that. Somebody back in 2013 had a valid use case. It went through a process. It was the code update was reviewed, and Jindy support was added to Log4j. Now, fast forward to 2021, and ultimately the decision was made that the use case was not useful enough to leave Jindy in there, and this box has now been removed, which disconnects all this other stuff down here. But let's just take a little walk through the park here to see what actually happens. When this string ends up in a logger message, it triggers a call to Jindy. And if you're not familiar with Jindy, we love our abstractions in Java. And Jindy allows us to have a common set of interfaces for different directory services. So DNS is a directory service. LDAP is a directory service. This interface gives us a common way to access them. And we start off with a URL looking string. And in this case, it's LDAP. So Jindy sees this LDAP coordinate, this LDAP URL, and it makes an LDAP call out here to what turns out to be a malicious LDAP server. Now that LDAP server returns a special type of LDAP response. LDAP usually is used for looking up people and organizations. It can even be used to look up devices on a network like printers. Microsoft's Active Directory is based on LDAP. But if the LDAP response is specially constructed, it can refer to a remote Java class. We'll see the code for that in just a little while. So the response from LDAP includes a reference to a remote Java class. Jindy happily goes and makes this HTTP request. A byte array is returned, which then gets deserialized. And one thing that's important to point out is this resulting evil class is not in the class path of my app. It's just using the magic of Java deserialization to materialize it. And then our last step is mayhem, in this case, rmrf/ as an example. But more realistically, if somebody were doing this exploit, they might exfiltrate a bunch of files. They might connect to an external server to snoop on your server. There's no limit to what could be done because of the nature of this exploit. So with that under our belt, let's dig into an example of the code here. And where we start is this fundamental problem that exists because of the Jindy stack. And if we look at this top bit of code here, there's about, 6 lines of code. But what gets us into trouble, and this is almost similar to a cross-site scripting error, if you're familiar with JavaScript vulnerabilities, what gets us into, or kind of like a SQL injection, is we have this unsanitized arg. In this case, our unsanitized arg is going to be this Jindy string, and that triggers that whole scenario that we just looked at. So let's take a look at an application where we'll be able to see how Log4Shell got its name. So bear with me a sec as I find the right thing. I'm going to fire up this Tomcat app. I'm going to show you what this Tomcat app does, and then we'll see the exploit in action. So I have a humble login screen here, and you can see that this is super secure because the password is showing there in plain text. And when I click login with the right user ID and password, I get into the app. Pretty straightforward. And now let's just say I mess up the username or the password. I fat finger a G here on the end. Now I get a message saying the password I entered was invalid. We're going to log your information. And what the code does is, let's see if I can highlight the bottom here. It uses our logger and it outputs the username that was mistyped. Now, again, we're dealing with unsanitized output. And if we look at the code here, we can see that it's very straightforward, obviously not production code. Don't do this at home. But we get a hold of our Log4J logger and we simply log the username. That is, whatever the user put in the username field, we log that right out. So I could do something like set up my interpolation, set up my Jindy string. So I could do something like that and try to log in. And then we can see that this Jindy string has now been written, unsanitized, unchanged. And behind the scenes, this actually triggered an attempt to make a connection to an LDAP server, but this LDAP server doesn't exist, so that just failed. But let's actually make this work now and see how this can be exploited. So this repo that I'm working with is open source. We'll make sure that we have the references to it, and it's got some moving parts to it. So let's take a look at each of these. You remember from our diagram, which I'm going to return to a few times, we need to have LDAP and HTTP running to close the loop on this and to exploit this. So the first thing I'm going to do is run an HTTP server. This is just a Python HTTP server, and it's just going to serve anything that's in the folder that it's run. So put a pin in that. We'll come back to that. There's our HTTP server. Now, the next thing I'm going to do is run this proof of concept Python. And you might be asking yourself, well, if this is all about Java, why are we using Python? Python makes it pretty easy to set things up, to set the stage for what we need to do. So let's take a look at this Python code and see what's going on here. I'll do a quick overview, and then we'll come back to it. It's going to ultimately result in running an LDAP server on the port that we tell it to. And then it's going to listen for incoming requests. And we're going to use a reverse proxy to give us shell access. Now, the payload here may look familiar if you're a Java programmer. Our payload, this is actually a Python here doc that is going to generate a Java file. And if we look down here, it's going to write out that doc into this Java file, and it's going to compile it. And then it's going to use this open source reference implementation of LDAP to listen for incoming LDAP calls. So there's a lot going on here. I will answer any questions if they show up. Use the Q&A. But the order of operations here is we're gonna write out a Java file. We're gonna compile it. Then we're gonna run an LDAP server that, combined with the HTTP server, is ready to return the byte array of the class file. Now, if you look over here on the side, you'll see that there isn't an exploit.java or exploit.class yet, but as soon as I run it, there will be. So let's go ahead and run this. I'm going to tell it for my LDAP, I want it to listen on localhost 80, and we're going to set up our reverse proxy at port 9001. That's what's going to give us shell access. Okay, so it's listening for LDAP requests on port 1389. I'm going to copy this string. And if I check back in with the project here, you'll notice that now there is an exploit Java class, Java file, and that's been compiled into a class. And now because I'm running my HTTP server in this same folder, it can return that exploit class. Now there's one more piece of the puzzle. Like I said, there's a lot of moving parts. The last piece is using the netcat utility. That's gonna serve as our reverse proxy. And now that's sitting there listening on port 9001, so that when we put all this together, it's gonna give us shell access. Well, let's take a look at this put all together. So now instead of a fake Jindy string, now this is a real Jindy string that's going to trigger an LDAP call. The LDAP call is going to trigger an HTTP call, which is going to result in a malicious class that's going to connect us to our reverse proxy. Let's see this in action. Excuse me. Now, if you look at the tab up top here, it's hung, or it appears to be hung, because what it's doing now is connecting to our reverse proxy, and it's given us now this shell access. But let's look at the moving parts again and see what's happening there. So first of all, we can see that the HTTP server returned exploit class. Well, what told it to do that? If we look at our LDAP server, the incoming request to the LDAP server sent a redirect, which caused the request to the HTTP server. Now we can see that a connection has been made to our reverse proxy, and it doesn't look like there's a lot going on, but this is effectively now given me shell access. Let me prove it. I'll type in a common Linux or in my case, Mac command. Who am I? Micah Silverman. Let's see what's going on in the folder that I'm in. Well, now I can see the contents of this folder. That's not good. How about, let's look at my password file. Well, that's really not good. So this is, what we're looking at is the reason that this was dubbed Log4Shell, because I now effectively have shell access. Last thing to look at in this segment is just a little view of the code here. Well, what enables this? It's really not a lot of lines of code. It's, you know, maybe 30 lines of code. All it's doing is using the Java process builder and calling bin shell. That's our shell. And then it's firing that up, and then it's using sockets to just ferry all of the input to the output on the shell, or vice versa, all of the output from my terminal to the input on the shell, and then we're seeing the result of that. So that's effectively giving us shell access. Now, this is a kind of a convoluted way. When we do the deep dive later, you'll see a simpler exploit that's just as dangerous, but this really demonstrates the shell nature and giving us access to the shell. So let me pause here just for a sec and take a quick look. It looks like some questions were asked and answered, so that's great. I don't see any currently in the queue, so I'm going to press on here just in the interest of time. And let's see, what is next? Oh, I know what's next. I don't want to just leave you hanging in the problem. Let's talk a little bit about remediation. So if you go to the front door of Snyk.io, we still have up right at the top all of these resources for Log4Shell. Getting there. And this brings you to a dedicated page with all of our resources, including the original CVEs. But from here, you can get to some important resources, not the least of which is the Log4Shell remediation cheat sheet. And I think I have it there. Yes. So here's the remediation cheat sheet. This is a great resource that our field CTO, Simon, put together. And the first two are really the most important. First step is identify where you have Log4j. Second step is updating to the latest version. That's really the best, most effective way to remediate Log4Shell. However, we recognize that you may be in a situation where that's not possible in the moment. Maybe over a weekend or in the evening, you'll be able to stop your servers and update and redeploy, but maybe you can't in the moment. And so then the rest of this remediation cheat sheet is about kind of stopgap measures. These are not the best practice for the long term. The best practice is to update to the latest version. But things like looking at your restricting egress, for instance. So if you don't have the ability to stop your service, upgrade the version, redeploy, and start it up again, at least for now, maybe you can adjust your firewall rules to ensure that no LDAP egress is possible. If you're using Log4j and you have no need of LDAP, you can just shut that down and then update the version when you have a chance. So this is a super handy resource, and again, you can get there right from the front door of Snyk.io. Another handy resource we set up is Awesome Log4Shell. It follows the Awesome format, and it's just a curated list of links that help you understand Log4Shell and help you deal with it. It's got proofs of concepts. It's got a bunch of discussions. It talks about known vulnerable software. There's a meme section because we got to have our memes. Let me just do a quick time check. I got about another couple of minutes before I turn it over to Eric. So one thing I want to show you live here for remediation is, let me shut everything down here. Okay, and if I go to vulnerable application, one of the things, among the things that Snyk did to respond to this was to add a Log4Shell command line parameter that is specifically hunting for Log4j. So maybe you're using a bundled jar that has Log4j buried in it, and you don't even use Log4j in your application, but there's some bundled jar or a fat jar or a shaded jar that's somewhere buried in it is Log4j. Well, this command will sniff it out. It will dig into your jar files, and you can see this is a very simplistic example, but you can see in the example app, it dug through WebInf and found this bundled up jar that, or it found in this case, it found the library directly. So Log4j core is where the vulnerability exists. But if I had a shaded jar or a fat jar, it would have found it within that. So it goes above and beyond the regular Snyk command line tool to inspect the bytecode that it finds within your jars to ferret out any instances of Log4j that may be vulnerable. All right, now I have gassed on for quite a while here, so let me pause there. I'm going to turn it over to Eric, who's going to give us a great insight into what's going on with Log4Shell in the world of containers, and then we'll wrap up with a deep dive into the code stack. So take it away, Eric.
Thank you, sir. Hold on a second. Let me get my screen share going. There we go. So as you just saw, I mean, it's pretty interesting how JNDI is available to you right from your logging platform, right? What I've done here is I'm going to show you how does this look in a container aspect, and specifically running in a Kubernetes cluster. What you'll see demonstrated here, this little diagram shows you I have just a Minikube cluster running on my laptop. You can do this on any compliant Kubernetes cluster. In the default namespace, I've deployed our Java Goof app, which is, if you've ever seen some of our presentations before, we have these Goof apps that are just purposefully vulnerable, and this one is vulnerable to Log4j. And I'm going to hit that on a service, if I get my focus right here, with our friendly LDAP JNDI string that Micah was just showing you. You're going to see that go in to the app, and then mayhem ensues. So let's get right to the demo. And let me get my screen going here. Okay, so on the right, you're seeing the Java Goof app. It's just a simple to-do list type thing. I'm going to log into it. Oops, and apparently my There we go. Okay, so demonstration of stuff here. On the left is a log of the output of this Tomcat server that's running this application. So if I do a search, let's say, you'll see there's a log line that I searched for car, or I could search for the word the, and you're seeing, you know, that's coming out. Now, let's say I get more fancy here, and I put our fancy JNDI string, LDAP, : / and I'm going to put in, so we can do this from memory. Notice the graffiti that just popped up here at the top. And you can see the log line. There it is, the unscrubbed log, just like Mike was showing in his example. What we just saw is the LDAP server spit back, you know, through that mechanism he showed, a class that searched around and found a JSPF in this container, or in this application, I should say, and just applied it to the header. So now anywhere I go has this nice graffiti. Now that's pretty innocuous. That's pretty silly, actually. More likely what would have happened is something more like what Micah showed. They could get a shell into your app, or honestly, they could start mining Bitcoin, or they could start setting up a beachhead in your process to start expanding their exploit. Now, just because we're in a container doesn't mean you're fully contained, if you will. When you exploit in a container, you have access to anything that container has access to. And pop back to this demo, and you can see what has happened here. I happen to be also running another namespace called Dark Web, but that's just for simplicity. This could be anything with a DNS resolvable host name. So ldap.darkweb returned the call to evil.darkweb, which returned that class. And that class had a shell in it that did that regex change on the JSPF. Now imagine, so we talked about firewalls a second ago, and one of the mitigation efforts you can make is to set up your firewall to block egress. Let me go back a slide, which would stop that. But if you've been doing application deployment for any length of time, you know that as your application grows, as your suite of applications in a microservice kind of environment grows, keeping track of what needs to be open versus what shouldn't be opened can start to become challenging. We'll say opening tickets with the firewall team, handling the rescheduling of pods across nodes in a cluster, making sure you've got all that set up can be challenging, especially if you do need egress access for other things. Well, Kubernetes does give us a feature to handle this on a very granular basis with a kind of a belt and suspenders kind of a situation. You should have perimeter firewalls. I'm not saying you shouldn't. But if you use network policy, you can also really lock down what your pods and the containers in them can do and what they can't. So let's take a look at what a network policy for this might look like. Now, while I'm doing that, I am going to kill the pod I was running to undo that exploit I did to it. So I've got K alias to kubectl. So we're going to delete pod that. Oops. K delete. Let's just use my autocomplete goodness and get it done. All right, that will reset my pod while we're going through this. Jump over to my editor. Now, network policy, a lot of developers like myself, when you first hear about network policy, you start, oh my gosh, network firewalls, this is going to be hard to understand. It's really not. Network policy simply is an API for defining what network traffic you want to allow or disallow between pods in your application, in your deployments, and in your clusters, really. They usually are based on a couple different things, but usually they're based on a selector. So you say any application that matches a certain selector, a label like app Eric or app front end, is allowed to do this kind of communication or is disallowed, or all sorts of different combinations of that. This is a very simplistic deny all type policy that's going to, when applied to the default namespace, which is where my app is running, it is going to apply to all pods. So the selector is wildcard, everything in there. It has an egress policy that says only allow, this is an allow list kind of a thing, only allow DNS traffic, basically. You kind of need that too, because in Kubernetes, DNS is your service lookup, so you don't want to block DNS. But that's the only thing we're going to allow. Now, of course, if I had a database to connect to, I would have extra lines in here to allow that as well. But let's go ahead and put this in, get into that directory. Actually, I'm in this tab. Okay, apply, no egress. So that has been applied. I'm going to start logging the new pod instance so we can see what's going on there. And let's go back up to the top level of my app. Sign back in. And just to make sure it works, we'll do a good search. That works. Now let's put in our JNDI string. Now it's sitting there hanging. Now what's really happening in the background is the Tomcat's, the thread running in the Tomcat server is trying to hit ldap.darkweb, and that egress policy is keeping it from happening. It's going to time out. This is not a silver bullet, but this can buy you time. Having this kind of extra belt and suspenders kind of security in place around your containers and your pods mitigates and makes the life harder for the hacker. The right solution, as Micah said, is to upgrade, get off of that bad version of Log4j, do what you can to fix your problem. But by having these kinds of things in place, it does make life harder for those bad actors. Now, additionally, when this is kind of a diagram of, we put a lock at the edge of that pod, and honestly, any pod starting in default right now is going to have that same restriction placed on it, unless another network policy that takes precedence is added. This also, as I said earlier, could have been anything. Dark web is just an easy one to set up in your cluster because DNS will give it to you. This could have been running out in the cloud somewhere, or on my own another server in the data center. And one thing that comes up, a question I'll often get here is, oh, well, do you have to have LDAP? If I don't allow LDAP connections, then I don't have an LDAP server to be exploited. There's not a problem. Well, imagine Eric takes his laptop to shady coffee house and gets malware on it, brings back into the corporate network, whether in person or by VPN, and logs into a Bastion host in my data center, and all of a sudden that malware wakes up and says, hey, let's set a reverse tunnel up and run an LDAP server here and see if we can, start finding things. There's all sorts of vectors of attack that can happen. So having the belt and suspenders of blocking the egress traffic right at your pods will help mitigate those kinds of things. And there's other things you could do beyond network with containers that can help out a lot. And the security context that you can define on your pods really can make life harder. And again, fixing the bug, most important. But let's say we went into, let's look at the deployment I did here. Now, if you've not looked at Kubernetes deployments before, this is a pretty basic thing. I'm declaring the state of the deployment, and it's just saying make one replica of this application that runs on, I do a little variable interpolation here, but this image, and name it Java Goof. Now, by default, this is going to run with whatever user the image is set up for. And by default, most open source base images start with root. If I'm root in the container and somebody exploits me with a remote code execution exploit like this, that exploit is happening as UID 0 in the container. And whatever the bad actor wants to do in your container, they're doing as root. They can modify file system. They can try to install software onto that, into that container, again, to try to exploit, expand their exploit. They might install an nmap and start poking around your network to see what else is available. So you can restrict what user a pod or a container runs as by adding a security context, and first and foremost, adding run as non-root true. By default, that is not the default. False is the default. This will, ignoring the next two lines, tell the kubelet when it goes to start the container, inspect that image and make sure it's not UID 0. And if it can't determine it, if it is UID 0, or if it can't determine that, it won't start the pod. You'll get a failed to start, and if you inspect it, you'll see, you've told me not to run as root, and I can't tell if this is going to be root or not, so I'm not going to run it. That's what kubectl will do. You can also explicitly say run as user and group and give it the UID GID. Now, in the Tomcat official base image, this is the nobody user. You can find that out by just kind of going to their documentation or looking at the, fire up a Tomcat server and exec into it and look at it. Now, you could also do this in your image, and I would recommend it. Make sure your default user be this, but I also like being explicit in my deployments. This would have, by having this right here, would have stopped the exploit I just showed you from being able to do the modification that it tried to do, because the nobody user does not have write access in that image, in that container, to change the JSPFs or anything else around there. It's not, again, not a silver bullet, but it's one more step, one more defense in-depth strategy to apply. Now, another thing you can do that I like is use the read-only root file system security context. When a container runtime engine starts up a container, the image layers are all read-only. And by default, it'll put a read-write layer at the top, and it then combines that to present to the process as a aggregated or layered file system. Any modifications to that file system are done with copy on write. It brings the file up and makes the modification in that read-write layer. If you start that container in read-only mode, which is what this setting will do, it doesn't put that read-write layer in there. So you effectively have a read-only file system for anything in that base file system. Now, of course, you got to be careful about any volumes you mount and make sure you're also applying good security there. The same thing here, though. Making your container file system immutable makes life hard on that hacker. They'd have to do some other things, put things in a RAM disk or something, whatever, to extend their hack. Again, not a silver bullet, but all of these things lined up, as a bad actor, if I'm looking for an easy target, you are no longer that easy target, and I'm going to move on to other, low-hanging fruit. And I think I ripped through that pretty fast, Micah. I think we're back to you. Yes. Oh, my slides have Q&A there. I think your slides are newer.
Yeah, all good. You do have one question, which I think I know the answer to, but I wanted you to put it in there before I messed it up.
Yes. So what is K, that magic K? I'm a lazy typer. That is an alias for kubectl. So you can set that up in your shell, and there's actually, you can set it up with bash complete and everything. But yeah, and anytime a lot of those of us who do a lot of Kubernetes work, you'll see that the first thing we do on a machine is alias K equals kubectl. Or kubectl or kubecontrol, depending on who you ask.
Kubectl, I like it. All right, let me jump back to sharing my screen. Thank you, Eric. That is excellent. And kind of like Python, I know just enough Docker and Kubernetes to be dangerous. And I'm still surprised that the default is to run as root, when in so many other security contexts we want to deny first, but good to be aware of that. Okay, so excellent. Okay, so to wrap up, we're going to do a deep dive. Oh, look at this. I still have my my program hung up here, so let me kill that. And before we jump into the deep dive code, I always like to, if you're kind of a vulnerability history nerd like me, you might find this interesting. And what I have on my screen right now is the original request to add Jindy to Log4j. Now, people may rightly ask the question, why does Log4j even have support for Jindy? And that's a fair question, but here's the answer. In 2013, going through the normal open source process, a request was made, and it basically said, hey, I have this use case that I'd like to be able to use Jindy for. Now, we can debate whether it was a valid use case or not, but it went through a process. The developer put up a patch which included this new class, Jindy Lookup, to add Jindy support to our humble logger. So this is kind of the double-edged sword with open source, where we have everybody's volunteering, and I have a particular use case, and it would be nice if the library, in this case Log4j, supported my use case. It's also useful to point out that this has been sitting dormant, we hope dormant, since 2013. That is a long time for a vulnerability to be kicking around. Another interesting data point is that at Black Hat 2016, there was a presentation that had 2 of the 3 components that make up what we now call Log4Shell. In particular, this was calling out the problem with Jindy and injection to other vectors of attack like RMI, but it focused on the LDAP vector. So Jindy and LDAP are a powerful conversation to take over a machine potentially. And this was identified in 2016. The interesting thing about this is that it was 3 years after this functionality was added to Log4j, and this presentation didn't mention Log4j at all. It was just talking about the Jindy and LDAP angle. So it took somewhere on the order of 8 years, we hope, for this to be disclosed. With vulnerabilities, when we put our security hats on, we always have to assume that if the vulnerability is there, somebody has quietly exploited it along the way, because a good hacker and a good evildoer will not make themselves known. So in terms of the timeline, what I always like to say is we're now in the middle of the timeline. The beginning of the timeline was 2013. The middle of the timeline was early December when this was disclosed. And now we may find, and I'm not wishing this, hopefully we don't, but we may find that in the future, we end up in an Equifax situation where this hole has been plugged, but somebody was lagging behind in updating their servers, their services, and an exploit ends up happening. Hopefully that won't be the case. Let's take a look at this code. And as I said earlier, this is part of our Java Goof app, which Eric was just demonstrating. So this is set up as Maven modules. So at the top, we have the Java Goof app, and one of the modules is this to-do list goof, but it's also got this Log4Shell goof, which is a standalone example. So the to-do list goof has a bunch of Log4Shell exploits built into it, which Eric demonstrated and added. It was a great addition to our repo here. But this is meant as a standalone. And one of the nice things about Maven multi-module projects is that you can get this nice class path separation. So if you notice in our Log4Shell client, the only file there is this main file. Then there's a server component. Now that server component is going to run our LDAP server and our HTTP server. And in the class path of server, we have this evil class. And part of the point here, part of what we're demonstrating is that there's no, this evil class is not in the class path of main, but it's going to end up there through the magic of network calls and deserialization. Now, just by way of setup, I just want to make sure that I'm in my start state. And what this version of the exploit is going to do is it's going to result in a file getting written to the file system as proof that this file system has been owned. So to start with, I'm deleting that temporary file. Because this is meant to be a standalone demonstration, it checks for the existence of the temp file, and it'll blow up right here if the temp file already exists, because then we're not really proving that it wrote this new file. So the first thing it's going to do is show some Java stats, like what version of the JVM you're using. It's then going to do a regular old logger call just to demonstrate that our logger is fully functioning. It's going to make sure the temp file doesn't already exist. Then it's going to output this, hopefully, what has become a familiar string here. And that's going to kick off this series of network calls that's going to result in a file getting written. We're going to sleep for a second. Terrible programming practice, but for demos, why not? And it's just because we're writing to the file system. So we just want to wait a beat and make sure that file actually gets written, because the last thing it does is to check temp again. And this time it should exist because the machine should have been owned through the magic of Log4Shell. So that is the code that we're going to debug through in just a second, but let's take a look at our server. Our server component, because we wanted this to be a freestanding, fully encapsulated demonstration, the server component runs a very lean HTTP server and an LDAP server. So it doesn't have any external library requirements. These are single purpose servers, so they're not, fully blown HTTP servers or LDAP servers, but they will respond for the purposes of demonstration. And so it's going to fire up the LDAP server, and then it's going to fire up the HTTP server, and then we'll be ready to go. So let me start by doing that. I'll fire up our server component. And if we look down here, we can see that it's listening. LDAP is listening on port 9999, and HTTP is listening on port 8000. Now, the next thing I'm going to do is I'm going to debug this main class. And one thing I want to point out here, it's easier with a modern JVM to debug deep into the stack. So the original exploit was with Java 8. The remote code execution was with Java 8, but you can pass along this command line parameter. Don't do this at home, where we can say trust URL codebase equals true, and then we can make a modern JVM like Java 11 misbehave in the way that we want to for demonstration purposes. So let me go and run that. Okay, so first breakpoint, we're about to make, we've in our main class, we logged out this string, and because of the interpolation and the Jindy URL, we find ourselves over here in Jindy lookup. And again, in the latest version 2.17.1, that file doesn't even exist anymore. But here we are, and we can see that it's about to make the LDAP call. So out of the Jindy string, it's pulled this LDAP URL, and it's about to make that call to this endpoint called evil. Let's let it continue. And now here's where things get interesting, and where the combination of Jindy and LDAP, it really comes into focus why this is a problem. Because unlike the usual case with LDAP, where we would return a CN or a DN or information about a user or a printer, we can also return this special set of attributes that kicks off that the Jindy stacks responds to. And so we have an object class, a Java code base, a Java factory, and a Java class name. The important thing for our exploit is the code base and the factory. The code base is this HTTP reference, and the factory is going to be evil. And the factory implements the object factory interface. And so when this class comes back and is deserialized, the Jindy stack is going to happily execute that method that's inside the factory. We're going to see that in just a second. So we'll continue on here. All right. Now at this point, if I look at my server output, we've made the LDAP request, and it responded with this HTTP reference. And we can see the attributes that came back over here on the right-hand side from LDAP, and let's continue on. Now here's where things get interesting. In our directory manager, which is deep in the stack, it's about to get an object factory from a reference. So the LDAP response was a reference, and now it's going to get an object factory from that reference. Now, if we look at what is factory, well, factory is this evil class. Through the magic of IntelliJ, even though evil isn't in the class path of the client, because it's in the class path of the server, which is part of this project, IntelliJ can happily show us what this is. So our factory is this evil object that's now been deserialized. And if we look back in our server console, we can see that the HTTP leg has been completed, and it just returned a byte array, which was that evil class. which our app here happily deserialized deep in the Jindy stack. And if we look at the evil class, it implements Object Factory. And so the next thing that's going to happen is this get object instance method is going to get executed. Now, what it should be doing is returning an object. In fact, we're returning null here because it doesn't matter. The only purpose of this class and method is to do something malicious. And in this case, it's setting up a command array, and it's going to echo out to this temp pwned file, and it's just going to use runtime get runtime exec, easy peasy in Java. So if we jump back to where we are, let's go here. And so here we can see where it's going to get the object instance. And so rather than step over this, let's step into it. And now we're inside the evil class, which didn't originally exist inside the class path of our application. So I'm going to let that run. I'm going to let it finish. And now we get the message, you've been pwned. So it wrote out, if I go back to my terminal, I started by removing the file. Well, now I can see that the file is back, indicating that we were compromised. So success from the perspective of being compromised. All right, well, that brings us to the end. I know it was a whirlwind tour here. Let me just check Q&A.
We do have one question that came in about JMS appender.
Oh, great. Yes. So one of the remediations is to remove the Jindy class altogether, which will help with the JMS appender as well, because JMS appender could also have a Jindy string. And I actually got asked this question earlier today, and apparently Log4j1 still has a JMS appender available to it. But it doesn't, it only retrieves strings remotely. It will not retrieve a serialized Java class. So there's less of a vulnerability. But what I advised the company that asked me this earlier today was in production, if you don't want that, in production, check your properties file and make sure that you just aren't using a JMS appender, and that kind of avoids the whole problem to begin with. Hopefully that makes sense.
Yep, I actually was talking with Brian Vermeer while you were talking about it, and one of the things he brought up, and this is, I don't believe that we would say this is a Snyk recommended approach, but if you absolutely must be on Log4j1, where JMS appender is still a problem, and Apache has no answer for you other than upgrade, really, no supported answer. There is another package called Reload4j, which is the original author of the old school Log4j forked it, and it's a different package that's, I believe, API compatible. You could look at that, but I think the official answer still is upgrade to the latest Log4j2, and the pain that might be involved in that.
Yep. Yeah, Reload is API compatible, and it is maintained by the original author, but you know, he's an individual. Apache's a whole foundation, so your mileage may vary. But as of now, Reload doesn't have any known vulnerabilities. Yeah,
I mean, but my thought is, as a former Java programmer, forking the library and removing JMS appender and whatever else you need to remove. I think Databricks has a good blog on this, actually, that talks about there's a couple other classes you might have to remove to be super safe, but you're now taking on support of your own library, and it might be a good interim quick hit, as our cheat sheet was talking about for the J&I piece, but you still want to get on that backlog to get upgraded or migrated.
Yeah, one other last thing that maybe is worth saying is that that same author who did the Log4j1 and is now maintaining Reload also authored SLF4j and Logback, and that has a huge community of support. That's what Spring Boot uses by default. So if you want to get away from Log4j, you have options there too with a well-supported alternative.
Good point. A couple other people have asked if this presentation and slides and recording are going to be made available. I believe so. Kenya, if you're on from VIB, are you going to be making the recording available?
Yeah, so we'll be sending the recording out to you guys, and then if you guys will be getting a recording from Snyk, it'll be just from them, not from VIB. So look out for that.
Okay. I know usually what we do is we'll post the slides in our Twitter feeds. So, Micah, what's your Twitter feed?
A fit nerd.
What? You broke up.
A fit nerd.
A fit nerd.
Yeah, I'll put it in the chat.
There you go. And I'm at Eric Smalling as it's spelled. So I'll retweet yours when you put it out.
Nice. All right. Thanks, everybody.
Thank you all for joining. This was fun.
Thank you, guys. That was a great presentation. And thank you to our audience for joining. And we will see you soon. Thank you.